All right. Hello, ladies. I am just going to be very quick, hopefully, and finish up the notes from class from the teaching day. And so this is the only problem we didn't get to. And the last problem, just so in example 6, just a little note for those who finished that problem. I believe your answer should have been, drum roll, I believe -2. So go back and check to make sure your answer is correct for that. And now the final problem, I wanted to give you an example of an absolute value with something other than a single term. So with what's called a binomial or anything larger than one term. The tip here is to isolate the absolute value first, okay? Remember I said you could do anything you want to an equation as long as you do it to both whole sides. And that's always true except divide by 0, and that's true. However, as we all know with equations, just like in life, there's always simpler ways and more efficient ways to do things, right? And so I'm just giving you a hint here to say to isolate the absolute value first. So if we do that, and before we start that, I also have this tip in here about solving equations with absolute value with some algebraic expression. So notice that this is a capital X, and it's a capital X because it's not standing for a single variable. It's actually standing for any expression you have. So X could be 3 x plus 5, x could be 3x squared, I don't know why I like 3's, minus 6 x plus 2, x could be 2y minus 17, x plus 4. It could be any type of expression. So in our case, this is representing that capital X. And that's why it's capital. It's not representing a lowercase x like I did in class, that example I did in class today. Okay. So once you isolate the absolute value, you're going to have the absolute value of whatever that expression is equal to some number. Okay. And then to solve that, you set up two cases. One where now you can take that expression outside of the absolute value, because remember, absolute value represents the distance, right? The distance from the origin. And so now we are taking it out into two cases. The first case is, well, that expression is just equal to that number P. And the second case is where negative that expression is equal to P, okay? Because of course we know that the absolute value, the output will always be a positive number because we're talking about distance, okay? And so let's look at our problem here. So it says solve for y. Okay, I wanted to change up the letters. Instead of solving for x, we're solving for y. Okay, so this is the original problem. Let's isolate the absolute value. So we add 7 to both sides. Then we get 3 times the absolute value of 2y minus 9 equals 12. Then divide by 3 on both sides. And so that will give us, all the way up here, the absolute value of 2y minus 9 equals 4. Okay. And so now we have our two cases. And so we have case 1, where 2y minus 9 equals 4. And then case 2, where negative 2y minus 9 equals 4. Okay. And now you can solve these from here. I won't bore you with that, but over here we see, what will we get? I think y, and of course you can correct me, not now, but in class. Y is 13/2 for this one. And here you could distribute that negative through. So for this second one, just in terms of thinking about being more efficient, of course you can distribute that through. But you also, there's always a 1 there. It's always a -1 there, in case you didn't know that. Just like negative x is really -1 times x. Okay, so there's always that -1 there. So what we can do is actually divide both sides by -1, and then we get 2y minus 9 equals -4. And then go ahead and solve. And I believe here, and if I'm incorrect, let me know in class. but y equals 5 halves. Okay, so a little over 5 minutes, but this is what I wanted to show you. Make sure you review your notes, and I will see everyone in class.